Imagine the Earth, but not as you know it. An alien world that is still our own, bathed in the light of a younger sun, with continents adrift in unfamiliar shapes across a vast ocean. We think of our planet's history as our own, a linear story that begins in dust and ends with us, with our cities, our art, and our dominion. But the Earth is 4.5 billion years old, a timeline so immense it defies human comprehension. If you compressed this epic into a single day, all of recorded human history would flash by in the last fraction of a second before midnight. This staggering reality forces us to ask a profound and unsettling question. What happened during all that other time? Are we truly the first chapter in Earth's long story of intelligence? What if, buried deep in the silent layers of rock, lies the ghost of a world that existed before we did? Our own existence is already writing an indelible chapter into the geological record. Future scientists, millions of years from now, will find a strange, unmistakable layer in the strata. They will see a sudden, violent spike in carbon, the fossilized remnants of our plastic waste, and the unnatural isotopes left behind by our nuclear ambitions. This layer, which many call the Anthropocene, will be our legacy, a planetary scar that screams, "We were here." It will serve as the unmistakable fingerprint of a global industrial civilization. This very fact that we are leaving such a clear signature is what opens the door to our investigation. If we are carving our story into the planet's memory, isn't it conceivable that someone or something else did so long before us? This radical idea isn't the stuff of late-night fiction. It was born from the rigorous minds of modern science. In 2018, Gavin Schmidt, director of NASA's Goddard Institute for Space Studies, and astrophysicist Adam Frank published a thought experiment that sent ripples through the scientific community. They called it the Silurian hypothesis, a nod to a fictional reptilian race from the television series Doctor Who. Their goal was not to find ancient aliens, but to ask a more grounded question. If an industrial civilization existed on Earth millions of years prior to us, what evidence would it leave? They turned their focus away from fantasies of buried cities and toward the hard science of geochemistry, looking for the subtle, planetary-scale consequences of industry itself. The primary obstacle to finding a predecessor is Earth itself. Our planet is a master of erasing its own past, a world in constant, violent flux. The Earth's crust is not a static library but a dynamic conveyor belt, with tectonic plates constantly shifting, crashing, and sliding beneath one another in a process called subduction. Over millions of years, entire mountain ranges are ground down to sediment by wind and rain, while new land is forged in volcanic fire. Any structure, no matter how monumental, would eventually be pulverized, buried under miles of new rock, or melted back into the planet's mantle. After a span of just a few million years, the odds of finding a single recognizable fossil of an inhabitant, let alone one of their tools, shrinks to virtually zero. So, if the planet erases all direct evidence, how could we find a lost civilization? Schmidt and Frank proposed we stop looking for a needle in a haystack and instead look for the ghost of the needle. You don't search for a fossilized car. You search for the global chemical anomaly caused by billions of them. This means hunting for indirect geochemical fingerprints, a global-scale forensics investigation. The clues would be subtle but massive in scope. A bizarre, sudden spike in carbon isotopes in sediment cores, indicating the mass burning of fossil fuels. You'd search for novel molecular compounds that nature doesn't produce, the long-degraded echoes of ancient plastics or pollutants. You might even find layers with unusual ratios of nitrogen, the telltale sign of planet-wide fertilizer use for industrial agriculture. The window of opportunity for such a civilization to arise is staggeringly vast. Complex life has flourished on Earth for over 500 million years, a period known as the Phanerozoic Eon. Within that immense timeline, our own species, Homo sapiens, is a recent arrival, appearing only about 300,000 years ago. Our industrial society, the kind capable of altering the planet's chemistry, is barely 3 centuries old, a geological eye blink. Given the millions of years available for life to experiment, for evolution to forge intelligence in different forms, it poses a question of probability. Is it truly more likely that the precise combination of intelligence and tool-making required for a technological civilization happened only once, in the last 0.001% of the time available? Or could we be just the most recent iteration? Contemplating the Silurian hypothesis does more than just challenge our understanding of history. It strikes at the heart of our identity as a species. We have a deeply ingrained sense of exceptionalism, a narrative that places humanity at the apex of evolution, the sole inheritors of consciousness on this world. The possibility that another intelligence could have risen, built a global civilization, and then vanished so completely that they exist now only as a faint chemical whisper in ancient rock is profoundly humbling. It suggests that dominion over this planet may not be a permanent title, but a temporary one. The idea forces us to confront our own cosmic fragility, to see our sprawling cities and grand achievements not as an eternal monument, but as a sandcastle on the shore of a cosmic ocean. This thought experiment, therefore, becomes the foundation for our entire investigation. Provides us with a new lens through which to view our planet and a new set of questions to ask of the deep past. We are about to embark on a journey into geological time, a detective story where the crime scene is the planet and the victim is a civilization that may have died out 60 million years before the first human stood upright. The clues are not in forgotten texts or buried ruins. They are locked away in the layers of the earth itself, a silent history waiting to be read. The question is no longer just, were they here? But what can their story teach us about our own? For if we are leaving the same kind of fingerprint, we must wonder if we are also heading toward the same silent geological fate. If a civilization rose and fell in the deep past, who were they? To answer that, we must look to the era when life on Earth was at its most alien, a time when our own mammalian ancestors were little more than fearful, scurrying creatures hiding in the shadows. For 180 million years, an unbroken age of dominance, the planet belonged to the reptiles. This was the Mesozoic era, an empire of scale and claw that lasted 50 times longer than the age of mammals has so far. They conquered the land, the seas, and the skies, diversifying into a breathtaking array of forms that stagger the imagination. It is in this lost world of giants that we must search for our prime candidate. The very idea of an intelligent dinosaur seems, at first, like a contradiction. We picture them as lumbering, instinct-driven brutes, creatures of immense size but minimal intellect. This caricature, however, is a disservice to their evolutionary success. Evolution is the ultimate innovator, and with nearly 200 million years to work with, it had ample time to experiment with the blueprint of the reptilian mind. To find our candidate, we must look past the titans like Tyrannosaurus or Triceratops and search for something more subtle, a creature with the biological prerequisites for higher intelligence. Our search leads us to the late Cretaceous period, to a dinosaur that broke the mold. It was a small, bipedal predator known as Truden. While not physically imposing, Truden possessed a set of remarkable characteristics that made it an outlier among its contemporaries. It had large, forward-facing eyes, suggesting excellent stereoscopic vision, a key trait for judging distance and manipulating objects. Its slender hands, equipped with partially opposable fingers, showed the potential for grasping and fine manipulation. These are not the features of a mindless brute. They are the raw materials from which tool use, and eventually technology, can be forged. But Truden's most compelling feature was hidden inside its skull. When scientists calculate the brain-to-body mass ratio, a rough measure of intelligence known as the encephalization quotient or EQ, Truden stands out. Its EQ was significantly higher than most other dinosaurs, approaching that of modern birds, which are their direct descendants and are known for their problem-solving abilities. This was not a human-level intellect, not even close, but it represents a clear evolutionary trajectory toward greater cognitive complexity. Truden was not the final answer, but it may have been the blueprint for a different kind of mind. Let us engage in a bold act of speculative biology. The age of dinosaurs came to an abrupt, violent end 66 million years ago when a 6-mile-wide asteroid struck the Earth. But what if it had missed? What if Truden, or a similar species, had been given another 66 million years to continue its evolutionary journey, the same amount of time that separates us from them? Paleontologist Dale Russell famously explored this idea in the 1980s, proposing the evolution of a dinosauroid. His model envisioned a creature that retained its reptilian ancestry but had been shaped by the demands of intelligence. Imagine this being. It stands upright, its bipedal stance freeing its hands for complex tasks. Its ancestral tail has shrunk, no longer needed for balance, while its skull has enlarged to house a sophisticated brain. The large, luminous eyes remain, but now they hold a spark of analytical consciousness, a gaze that measures and understands the world. This creature would not be a mere monster. It would be the planet's other child, a sentient being forged from a different evolutionary fire, a saurian intelligence whose thought processes might be as alien to us as its physiology. What kind of civilization would such a mind create? A society born from a cold-blooded, reptilian lineage might prioritize logic and efficiency over the emotion-driven social structures of mammals. Their architecture might not be built of steel and glass, but rather grown, using advanced bioengineering to create structures resembling termite mounds or coral reefs on a massive scale. Their technology could be seamlessly integrated with biology, a world of living machines and organic computers. This wouldn't be a human society in a reptilian costume. It would be a fundamentally different mode of existence. This is, of course, speculation, but it is not fantasy. It is an extrapolation based on a real animal and the known principles of evolution. By envisioning this lost world, we are not just indulging a whim. We are acknowledging the sheer, unbridled possibility inherent in life's long history. The existence of a creature like Truden proves that the ingredients for intelligence were present on this planet long before we arrived. The question is whether they were ever allowed to finish baking. To find out, we must now turn from the realm of biology to the cold, hard facts written in the stone beneath our feet. Having imagined who our predecessors might have been, we must now leave the realm of speculative biology and enter the world of hard evidence. Our investigation pivots from flesh and bone to the silent, stone archives of the Earth itself. The hunt for a lost civilization is not a matter of archaeology, digging for shattered pottery or the foundations of forgotten cities. The immense timescale guarantees that any such artifacts would have been ground to dust millions of years ago. Instead, our search is for a ghost, a chemical echo imprinted on a planetary scale. We must become geological detectives, looking not for a body, but for the faint outline of a shadow it once cast. To know what to look for, we must first look in the mirror. Our own industrial civilization is currently creating the exact kind of evidence we seek. We are a geological force of nature, and our fingerprint is made of carbon. By burning colossal amounts of fossil fuels, coal, oil, and gas, we are releasing ancient, stored carbon back into the atmosphere at a breathtaking rate. This planetary-scale act of combustion is altering the chemistry of our oceans and atmosphere, leaving a permanent signature that will be visible in rock layers for eons to come. This signature, the Anthropocene layer, is our template. It is the Rosetta Stone for deciphering the deep past. The key lies in the type of carbon we are releasing. All carbon is not created equal. It comes in different isotopes, primarily carbon-12 and carbon-13. Living things like the ancient plants that formed our fossil fuels have a strong preference for the lighter carbon-12. Therefore, when we burn these fuels, we flood the atmosphere with an unnaturally high ratio of light carbon. Scientists can read this ratio in sediment cores and ice samples with incredible precision. A sudden, global spike in carbon-12 within the geological record would be a powerful indicator, a geochemical smoking gun suggesting that someone or something was running a global industrial engine. And when geologists look back through time, they find exactly such an event. It happened roughly 56 million years ago, a period called the Paleocene-Eocene Thermal Maximum, or PTM. Over a few thousand years, the Earth's temperature soared by 5 to 8 degrees Celsius, a terrifying episode of runaway global warming. And when scientists analyzed the rock strata from this period, they found a massive negative carbon isotope excursion, a giant spike of precisely the kind of light carbon associated with fossil fuels. The PTM is the closest historical analog we have to our current climate crisis. It stands as a stark and ominous event, forcing us to ask, what caused it? The conventional scientific explanation for the PTM points to massive volcanic eruptions or the sudden release of methane hydrates from the ocean floor. These natural events could certainly release enough carbon to trigger such a catastrophe. However, the exact mechanism and the speed of the carbon release are still subjects of intense debate. While the event may have been too slow to perfectly match our modern industrial spike, the data is not conclusive. The PETM remains an intriguing possibility, a geological ghost story. Could it be the faint, eroded signature of a forgotten industrial age? Was this planetary fever the result of a natural disease, or was it self-inflicted? But a true industrial society would leave behind more than just a carbon footprint. We are contaminating our world with substances that nature never invented. Our plastics, pesticides, and industrial chemicals are now found in every corner of the globe. While these complex molecules would break down over millions of years, they might not vanish completely. It's possible they would degrade into simpler but still distinctly artificial compounds, unusual molecular fossils that would signal the presence of advanced chemical synthesis. Finding such a molecule in ancient sediments would be an electrifying discovery, akin to finding a circuit board in a dinosaur fossil. The search for fingerprints extends even further. Modern agriculture, which feeds our billions, relies on the industrial production of fertilizers, a process that dramatically alters the planet's nitrogen cycle. This, too, leaves a detectable isotopic signature in the sediments of lakes and oceans. And then there is the most unambiguous and terrifying marker of all, radioactive isotopes. A global nuclear war or the widespread use of nuclear power would litter the globe with long-lived elements like plutonium-244 that have no natural source on Earth. To date, no such anomalous isotopes have ever been found in pre-human geological layers, a powerful, though not definitive, silence. Ultimately, the key may not be a single piece of evidence, but a devastating combination. A natural event might explain a carbon spike, but could it also explain a simultaneous spike in synthetic compounds and nitrogen anomalies? A true industrial signature would likely be a symphony of disruption across multiple, independent chemical signals all appearing in the same geological instant. It is this complex, multifaceted pattern that would be the most difficult to explain by natural causes alone. The challenge for scientists is to disentangle the faint notes of a potential industrial chorus from the loud, chaotic noise of the Earth's own geological processes. So the search continues. Teams around the world drill deep into the ocean floor and the Antarctic ice sheets, pulling up cores that are frozen libraries of Earth's history. Each layer is a page, and within each page they hunt for anomalies, for a pattern that looks eerily familiar. They are searching for the echo of another Anthropocene, a warning whispered across the abyss of geological time. The evidence so far is inconclusive, filled with tantalizing possibilities and profound silences. But the very fact that we can even conduct this search forces us to reconsider our planet's history, and to wonder if we are reading a story that has been written once before. If a civilization of intelligent beings once ruled this planet, their story ends in an unnerving silence. The geological record, which may hold the faint chemical signature of their existence, also chronicles their disappearance. This brings us to the most sobering question of our investigation. If they were here, where did they go? In the study of cosmic life, there is a concept known as the Great Filter, a hypothetical barrier so difficult to overcome that it prevents nascent life from achieving a durable, starfaring existence. The silence of our hypothetical predecessors suggests they encountered such a filter, one they could not survive. Their extinction is not just a historical event. It is a cosmic warning. The most obvious and spectacular suspect arrived from the cold, dark void of space. 66 million years ago, a 6-mile-wide asteroid, traveling at over 40,000 miles per hour, slammed into the shallow seas of what is now the Yucatan Peninsula. The impact was an almost unimaginable release of energy, equivalent to billions of atomic bombs. It vaporized a hole in the crust nearly 20 miles deep, triggering megatsunamis that washed across continents and ejecting a superheated cloud of rock and dust that enveloped the entire planet in darkness. This single cataclysmic event, the Chicxulub impact, drew a definitive line in the history of life, ending the 180 million-year reign of the dinosaurs. Imagine this moment from the perspective of our hypothetical saurian civilization. Picture their sprawling bioluminescent cities, their mastery over genetics and energy, their deeply ordered society. Now picture them looking to the sky as a new, terrifying star grows brighter by the hour. All their knowledge, all their technology, all their philosophy would have been rendered utterly powerless against this celestial hammer blow. The initial impact would have incinerated everything for 1,000 miles. But the true killer was the aftermath, a planetary winter. The dust cloud blocked the sun for years, killing the plants, starving the herbivores, and collapsing the entire global food chain. It was an extinction event that reset the course of evolution on Earth. This cosmic lottery, the random chance of an asteroid strike, is a terrifying but somehow clean explanation. It paints our predecessors as tragic victims of a fate beyond their control. But there is a darker, more disturbing possibility we must confront. What if the Great Filter was not an external force? What if it came from within? This is the most chilling aspect of the Silurian hypothesis, for if a civilization destroyed itself, its downfall becomes a dark mirror, reflecting our own deepest anxieties about the path we are on today. Consider the very fingerprint we are searching for, the carbon spike. An industrial civilization, by its nature, consumes energy and alters its environment. The PTM event, our geological case study, paints a picture of a planet in the grip of a catastrophic fever. Could this have been their undoing? Perhaps their technological ascent was so rapid, their consumption of fossil fuels so voracious, that they triggered a runaway greenhouse effect they could not reverse. We can imagine their final generations watching helplessly as their oceans acidified, their coastlines vanished beneath rising seas, and their world became an uninhabitable hothouse, a planetary-scale suicide brought on not by malice, but by their own unbridled success. Or perhaps their end was quicker and more violent. Intelligence does not guarantee wisdom, and tribalism is a powerful evolutionary force. It is conceivable that our Saurian civilization, for all its intellectual achievements, never outgrew its primal instincts for territory and dominance. What if their world was fractured into competing nations, each armed with technologies that made our own weapons of mass destruction look like toys? Their final chapter might not have been a slow burn, but a brilliant, searing flash. A global war fought with forces that cracked the very crust of their planet, poisoning their atmosphere and ensuring that no victor would be left to claim the ashes. There is another, more insidious path to self-destruction. A civilization capable of industrial chemistry is likely also a master of biology. They may have unlocked the secrets of their own genetic code, achieving wonders of healing and longevity. But this power is a double-edged sword. A single miscalculation in a lab, an engineered virus designed for one purpose that mutates to serve another, could unleash a plague against which their own advanced medicine was helpless. In their quest to perfect life, they may have inadvertently engineered their own perfect extinction, a silent, microscopic killer that swept across their planet and left no one behind. Whether it was an asteroid from the heavens, a planet choked by its own industry, or a civilization consumed by war or plague, the result is the same: silence. The story of their cataclysm is the ultimate cautionary tale. It suggests that reaching a certain stage of technological power is also to stand on a precipice. The Great Filter may not be a single event, but the inherent challenge of wielding godlike power without godlike wisdom. The empty throne of Earth, the one our species now occupies, may not have been vacant by chance. It may have been abdicated, and the silence of its former occupant is a message, a warning carried across 60 million years, asking a single terrifying question: will you be any different? Our journey so far has been one of bold speculation, guided by the tantalizing possibility of a world before our own. We have imagined a civilization of intelligent reptiles and explored the catastrophic events that might have erased them from history. But now we must anchor ourselves to the bedrock of the scientific method, which values skepticism as its highest virtue. For any great claim to be accepted, it must survive the most rigorous scrutiny. We must now turn the full force of that scrutiny onto the Silurian hypothesis and confront the deafening silence at the heart of our investigation. The most glaring hole in the theory is the complete absence of biological evidence. The fossil record, while imperfect, is a vast library of past life. We have unearthed the remains of countless species from the Mesozoic era, from colossal sauropods to minuscule insects preserved in amber. Yet, in over 2 centuries of paleontology, across every continent, we have not found a single fossil of our hypothetical saurian. We have found no remains of their potential livestock, no evidence of their agricultural crops, and no trace of their urban pests. For a civilization of billions to have existed without leaving a single, fossilized bone, tooth, or footprint behind defies statistical probability. Beyond the biological lies the technological. An industrial civilization is, by its nature, a society of builders and makers, produces artifacts, tools, and structures on a massive scale. While the Earth is a master of destruction, it is not perfect. Certain ancient, stable parts of the Earth's crust, known as cratons, have survived relatively unchanged for hundreds of millions of years. Even so, not a single unambiguous artifact has ever been recovered from these pre-human layers. There are no strangely machined tools, no fragments of non-natural alloys, no fossilized plastics. The legions of geologists and paleontologists who have meticulously mapped these ancient landscapes have found only the products of nature. Furthermore, a global industrial society would leave scars on the planet itself, wounds far too large for time to completely heal. Our own civilization has carved its presence into the Earth's surface through mining, quarrying, and tunneling. We have created open-pit mines that are visible from space and moved mountains to extract resources. These are not trivial changes. They are massive geological alterations. A precursor civilization would have needed to do the same, excavating vast quantities of coal and minerals. Such immense scars and the unusual concentrations of refined materials they would leave behind should be detectable in the rock record. Yet we find no such evidence. Even the tantalizing chemical clues we have examined fall apart under closer inspection. The carbon spike of the PTM, while fascinating, has several plausible natural explanations that do not require us to invent a lost civilization. Massive volcanic activity or the sudden release of oceanic methane are far simpler and better supported theories. Science operates on the principle of Occam's razor. The simplest explanation is usually the best. Without the discovery of clearly artificial pollutants or unambiguous radioactive isotopes alongside the carbon, the natural explanation remains the most rational. The chemical ghost we have been chasing may just be a trick of the light. Perhaps the most damning piece of evidence is buried right beneath our feet. An industrial revolution requires a massive source of cheap, accessible energy. For us, this was the fossil fuels coal, oil, and gas that powered our ascent. These same deposits existed in the late Cretaceous, and likely in even greater abundance. If a Saurian civilization had undergone its own industrial revolution, it would have inevitably consumed vast quantities of these resources. And yet, when we drill down, we find these ancient coal seams and oil fields largely untouched. Their pristine condition is a powerful silent testament, suggesting they were never exploited by a previous industrial power. It is crucial to remember the original purpose of the Silurian hypothesis. It was proposed by Schmidt and Frank as a thought experiment, not a claim of discovery. Its primary goal was to help us understand what our own geological signature, the Anthropocene, will look like to scientists of the distant future. By asking, how would we find a past civilization? And then finding no such evidence, we learn about the durability of our own markers. We learn what evidence survives and what is erased. In this sense, the hypothesis is a profound success, providing us with a critical tool for astrobiology and for understanding our own long-term impact on the planet. So, while the story of a lost reptilian world is a powerful and compelling narrative, the case for its absence is overwhelming. The utter lack of fossils, artifacts, industrial scars, and unambiguous chemical fingerprints leads us to a clear, if less romantic, conclusion. As far as all available scientific evidence can tell us, we are the first. The throne of intelligence on Earth was not abdicated. It was empty, waiting for a species with clever hands and an insatiable curiosity to claim it. This realization is not a disappointment. Instead, it is a profound clarification of our role. The silence of the past does not diminish our story. It magnifies its importance and places the weight of the future entirely in our hands. We began our journey with a ghost story, a tale whispered from the deep rock of our planet. We asked if we were the first, if another intelligence had risen and fallen millions of years before us. We gave it a face, a creature of reptilian grace and formidable intellect. We searched for its chemical signature in the strata, we contemplated its fiery demise, and we held its story up to the unforgiving light of scientific scrutiny. In the end, we found only a profound silence, a history empty of all but natural wonders and the slow, patient march of evolution. But the purpose of this investigation was never truly about discovering a lost world. It was about understanding our own. The Silurian hypothesis is the most powerful kind of thought experiment, for it is not a window but a mirror. By searching for the reflection of a forgotten civilization and finding nothing, we are forced to turn and face ourselves. The empty past does not close a chapter. It forces us to read the one we are writing right now, with a newfound sense of clarity and urgency. And what a chapter it is. The signature our civilization is leaving behind will not be a faint, debatable anomaly like the PTM. Our mark, the Anthropocene layer, will be a brutal, unmistakable scar across the face of the planet. Future geologists will find a shocking concentration of refined metals, a global strata of plastic polymers, and a thick blanket of concrete. They will find the bones of countless species we have driven to extinction and the strange, long-lived radioactive isotopes that scream of nuclear power. Our footprint will not be a whisper. It will be a roar. The scientific consensus that we are first carries with it a monumental weight. There is no one else to blame for our mistakes, no ancient tale of hubris to serve as a simple guide. We are, as far as we know, the planet's first and only experiment in technological consciousness. This realization strips away any notion of cosmic destiny and replaces it with a stark responsibility. Our successes and failures are entirely our own, and their consequences will echo through a future that has no precedent. We are not just living on Earth. We are defining what it means for a world to become self-aware. This brings us back to the Great Filter. We searched for the cataclysm that destroyed our imaginary predecessors, an asteroid, a self-inflicted climate catastrophe, a final global war. But we were looking in the wrong place. The Great Filter is not a historical event buried in the deep past. It is a clear and present danger. It is the rising line of carbon dioxide in our atmosphere, the ever-present threat of nuclear arsenals, and the accelerating collapse of biodiversity. The hypothetical end we imagined for a saurian race is the very real set of challenges we face today. The filter is not behind us. We are passing through it right now. What, then, will be our legacy? When future explorers, whether from this world or another, examine the thin layer of rock that represents our time, what story will it tell? Will they see the geological signature of a brilliant but fleeting species, one that burned through its inheritance in a geological instant and then vanished? Or will they find the foundation of something new and enduring? Will our layer be seen as a tombstone, or as the bedrock upon which a sustainable planetary-scale civilization was finally built? The choice is not for them to interpret. It is for us to make. From the perspective of deep time, our individual lives are impossibly brief, but our collective impact is terrifyingly permanent. The decisions made in our boardrooms, our parliaments, and our homes are being recorded into a history book that will last for millions of years. Our waste, our emissions, and our extinctions are becoming fossilized truths. We are the ancestors of a future that will judge us not by the words we spoke or the ideals we held, but by the indelible chemical and biological record we leave behind. We are carving our epitaph into the body of the Earth itself. In the end, our journey to find a lost world has led us directly back to our own doorstep. The silence of 60 million years ago serves only to amplify the noise and fury of our present moment. The question of a prior civilization was a way to ask the only question that truly matters. Can a species become a technological force of nature without destroying itself? The past offers no answer. The future is unwritten. We stand alone, in the quiet of a planet that has never done this before, holding the pen. The story of intelligence on Earth is our story, and it is only just beginning.